Yeah, I mean, I think if I were to guess, we'd probably go more into like more trig stuff because I don't think we're completely done with trig, but like we've just finished like a relative, like we've just finished like doing it, and yeah.
How did it go? Did you have any questions about it, or does it all feel like it's making perfect sense at this?
Felt really good, I'm not gonna lie, but
Thank you for not lying finally this time.
yeah.
Um, I was worried about you last week. Just kidding. So we're looking at the unit circle here, um, and you could see here on the x-axis. That's it right here. We have one, right? Okay. But if I were to draw, like, say, this dotted line right here, this also would be equal to 1, right? Because the radius is 1. If I were to draw it over here, this would also be equal to 1, right? Hence, it is a unit circle. Everything on here is equal to 1. On this unit circle, now I can expand just like one section of it. So I'm going to expand everything in the first quadrant and just kind of draw this here. Again, this is just 1/4 of the unit circle. If I draw a line now from here at a 45-degree angle to right there, this is still 1 and this is still 1. But from this dot here, I'm going to drop an altitude or draw a line straight down to the x-axis and create a 90-degree angle. All right? Now, we're going to say that this is a 45-degree angle here, right? Which automatically, obviously, makes the other angle what?
45.
It also makes it 45 degrees, which means we have what kind of a triangle here?
45, 45, 90 triangle.
Great. So you could probably get me the other two sides of this triangle, right?
Yep.
What are they? And how are we going to get them?
You just divide 1 by radical 2.
Great. Great. Now I want, so basically we're going to take 1 divided by radical 2, because in a 45, 45, 90, to go from the hypotenuse to the other two sides, we divide by radical 2, right? And so is that our final form?
No, it would be 1 radical 2 over 2. Because you multiply that equation by radical 2 over 2.
Great. Getting us radical 2 over 2. Terrific. So both of these two sides here are radical 2 over 2. Great. From this, I'm just going to move this up just a little bit so we can write this down. Actually, we can get the sine of 45 degrees, right? What would the sine of 45 degrees be based on the triangle we're currently looking at?
It would be opposite over adjacent.
Mm-hmm. So if we're at the 45 degrees, looking outward toward these various different sides here, right? Well, which side would be the opposite?
I mean, we have everything, so I don't really see what we're trying to find.
We're trying to get the sine. We don't currently have the sine of 45 degrees. We have the different sides of the triangle.
But how would it be sine? Because, like, you could also do, like, opposite over adjacent, which is tan, because we have.
That's right. We can get all of them. You're ahead of me. So, sure.
Okay.
Let's also get the cosine of 45 degrees. Let's also get the tangent of 45 degrees. Don't let me stop you.
No, I was just a bit confused. That's all. Okay.
Let's get all three of them.
Cool. Okay. So the sine is opposite over hypotenuse. So it would be radical 2 over 2 over 1.
Over 1. Great. Which just, obviously with a 1 in the denominator, it just reduces to just radical 2 over 2, right?
Yeah.
What about the cosine of 45 degrees? Cosine, using SOHCAHTOA, we know that the cosine is equal to what?
adjacent over hypotenuse.
Great.
This
So
must
what's the
be the
adjacent
same
here?
thing.
Radical 2 over 2 over 1, which is just equal to radical 2 over 2. And the tangent of 45 degrees?
Uh, Tangent is opposite adjacent, so that's radical 2 over 2 over radical 2 over 2.
Great. Which is, if we reduce that, equal to what?
1?
Yeah, because anything over itself is just equal to 1, right?
Yeah.
So in fact, if we were going to create a chart here, I'll make this chart right here. Let's say that we want the sine, the cosine, and the tangent. I'm just going to draw lines down here and lines here. And we want sort of the three main angles that we see repeatedly, which would be a 30-degree angle, a 45-degree angle, and a 60-degree angle, right? So just now we got the sine, cosine, and tangent of 45 degrees, so we can just go ahead and fill that in, right? We know that the sine of 45 degrees is equal to radical 2 over 2, the cosine, radical 2 over 2, and the tangent is equal to 1, right?
Okay, yeah.
All right, cool. Can we now get the sine, cosine, and tangent of 30 degrees? And how would we do it? Well, let's go back to our unit circle here, okay? So I'm gonna leave that chart up there on the left, and I'm gonna redraw just that first quadrant of the unit circle right here, okay? But this time, instead of drawing a 45-degree angle, I'm gonna draw a 30-degree angle. Put it right here. I'll put this here. Put a 90-degree angle there. 30 degrees here, and let's just go ahead and call this A, B, and C. What is the missing angle in our triangle here?
60.
60 degrees. Great. So help me fill in the sides of this triangle.
Okay, yeah.
What's the one side we already know?
We know a side.
Well, that's what am I teaching you right now? What are we working on?
Oh, the 1. Yeah, sorry.
Because it's called a unit circle, right? Exactly. So we know that which side is equal to 1?
AC.
AC is equal to 1. How do we get the other two sides now?
Okay, yeah. So AB would be equal to, what is it? It's just 1 divided by 2.
Correct. Or another way of saying that is 1/2, right?
1/2, yeah.
All right, great.
And then it would be 1/2 times radical 3
Which is?
for BC.
Yep. What is 1/2 times radical 3?
Would it not be 1/2 radical 3?
Well, let's write it down here. So if we have 1/2 times radical 3, if we want to actually merge these two things together, usually with multiplication, if we've got a fraction, the other one also needs to be a fraction, right?
Okay, yeah. So it'd be radical 3 over radical 3.
Radical 3 over 1. You can't just shove a radical 3 in there.
That is true.
Right? So what you're used to doing now is like rationalizing denominators, right? By multiplying by a radical 3 over radical 3, because that's equal to 1, so you're allowed to do it, right? But here we're actually just multiplying. You're not introducing a radical over itself. We're just saying, what is 1/2 times radical 3? So you have to just put a 1 in the denominator there.
Okay, yeah. So it'd be radical 3 over 2.
There we go. And that is the third side, right?
Yeah.
Great. So how do we now get the various different, uh, 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 you know, trigonometric values?
Okay, yeah. Well, we can get actually both 30 and 60 from this triangle. So let's start with 30.
Okay,
So, um,
great.
okay, start the sine. The sine of 30 would be 1/2 over 1.
1/2 over 1, which obviously is just equal to 1/2, right?
Yeah.
Great. What would be the cosine of 30?
Uh, the cosine is adjacent hypotenuse.
Adjacent over the hypotenuse. Good.
Which is radical 3 over 2 over 1.
Mm-hmm. Which just is equal to radical 3 over 2, right?
Yeah.
Good. And then if we want the tangent,
The tangent of 30 is 1/2.
because it's opposite, right?
Yeah, opposite. And then
Opposite over
over radical 3 over 2.
over adjacent. Good. So now we have 1/2 over radical 3 over 2. So how are we going to simplify that? Just move this up here for a second.
Oh, shoot, I forgot.
And notice that, by the way, what we're getting here, instead of getting decimal answers, instead of using our famous trigonometry chart or using our graphing calculator, we're actually getting answers to what the sine, cosine, tangent of all kinds of measurements are, right? But without using any of those things. We have it here in our chart, right? Using radicals and so on.
Yeah.
Do you know how to simplify this?
No.
Ah, okay. You've done it a million times, so let's just refresh our memory here. What are we looking at here? We're looking at a giant fraction, right? And what is a fraction but one number over another number, right?
Yeah.
What symbol does that look like?
A division symbol.
Division symbol. So what we're really doing is dividing. 1/2 divided by radical 3 over 2. In fact, I can just write that out. 1/2 divided by radical 3 over 2. That should start to kind of get your brain percolating here, right? How do we solve just a division problem with fractions?
You just do like the damn, I'm in this one. You just do a cross multiplying thing or whatever.
Cross multiplying?
No, but like not cross multiplying, like the switching thing. You switch
Yeah. Multiply by the, what do we call it? What's the word for? By the reciprocal. So we're going to leave 1/2 the same, change the division to a multiplication, and then change radical 3 over 2 to what?
2 over radical 3.
There we go. All right. And now what happens?
That's 2 over 2 radical 3.
Okay. It's equal to
Oh, yeah.
2 over 2 radical 3. And now what?
I guess that would just be question. So, since it's 2 over 2 radical 3, you would divide the 2 by 2, and that would be 1.
Yeah, we can.
1 over radical 3, or does the radical 3 jump up?
No. Anything that's in a, you got to think about fractions like they're 2-story houses, right? So if something's in the bottom floor of the house, it can't just automatically jump up to the top floor, right? It just can't happen. Sometimes we get a reciprocal and we can flip everything, but there's no way radical 3 can just jump up there. Got it? So yeah, but you're correct. The 2's are going to cancel out, right? So the top 2 is going to become a 1, bottom's going to become a 1, and we really just have 1 over radical 3. But we're not done there, right? Still a little more work to go.
Yeah, and then we multiply that by radical 3 over radical 3, which it's
Good. Just to rationalize the denominator, right? And so what do we get?
it's just radical 3 over 3.
Terrific. Terrific. So after all that crazy complicated work, we've gotten that the tangent of 30 degrees is equal to radical 3 over 3. Right?
Yes.
Now, when we look at our drawing over here, if we want, we could just use the 60-degree angle from this same triangle, or we can just draw another triangle right here, and just say, hey, that right there is going to be another. We'll just say it's a. I'll change the color to make it more visible, but we can call that a 60-degree angle, and this is our 30-degree angle this time, right? And this time our hypotenuse is over here, so we'll just put a 1 there so that we remember that the length of the hypotenuse in our unit circle is equal to 1. Let's get the other two sides of that triangle.
Okay, yeah. Cool.
And I'll label these also. So let's call this D up here, and let's call this point right here, we'll call that E.
Okay, yeah. So CE would be 1/2.
1/2.
DE would be 1/2 times radical 3.
Which is
We did this somewhere. I'm just
right here.
yeah. It's radical 3 over 2.
Making sense?
Yeah.
Great. So since we know what the lengths of all the sides of this triangle are, we can now get the sine, cosine, and tangent of 60 degrees. So let's do that. Just kind of go over here. All right, so the sine of 60 is equal to what? Sine is always what over what?
Opposite over hypotenuse,
Great.
which in this situation would be radical 3 over 2 over 1.
Which is equal to? There we go. All right, so the sine of 60, radical 3 over 2. Let's just go ahead and put that right here. All right. And now let's do the cosine of 60.
Yeah, okay. The
Cosine is always
sine would be adjacent over hypotenuse.
cool, which is equal to
1/2 over 1, which is 1/2.
great. Just filling out the chart. And finally, the tangent of 60.
Okay, the tangent. Tangent would be opposite over adjacent. And that would be radical 3 over 2 over 1/2. Which now I know how to do.
Yeah, anytime you get these crazy complicated fractions, I'd love for you to remember just multiply by the reciprocal, right? Because it just comes up so much, comes up on the SAT, etc.
Oh, yeah.
And in a million different forms, you know. Sometimes it's with radicals, sometimes it's all kinds of things, right? So how do we solve this?
You put them like in a division
So radical 3 over 2, what? Times or divided by?
divided by 1 over 2.
Yeah. So okay, I see what you're doing. So we'll start with that, and then we can change it into a multiplication problem, which is
Radical 3 over 2 times 2 over 1.
there we go. Now, last time you didn't cross cancel, but check it out. You really can here, right?
You can, yeah. The 2's just become 1.
Right. And so what do we have?
Radical 3.
There we go. And over 1, which is just radical 3, right?
Yeah.
And this time we don't need to rationalize any denominators because we've got exactly what we want, right? And so there you have it. I mean, without any charts, without any graphing calculators at all, we have the sine, cosine, and tangent of 30, 45, and 60 degree angles. As much as you're going to hate to do it, you really are going to have to memorize this chart.
Really?
Sorry. because you're gonna use it. Your teacher's gonna give you problems like this. Your teacher's gonna give you a problem like the tangent of 30 degrees divided by, say, like the sine of 60 degrees. That'll be an assignment, and then your teacher will say no calculators allowed.
Damn.
Right? Now, what if we don't have that chart sitting right in front of us? What are we going to do to solve this?
I mean, you could go and do a unit circle.
Create the unit circle. So let's do it real quick, right? So, and again, do we need the whole circle? Not really, right? We can just use the first quadrant. That was a terrible circle, but who cares? So we're going to go ahead and draw this real quickly. Put this here, draw this down. Go ahead and say that this is a 30-degree angle. Of course, here's our 60. We know this is 1 right here. So how do we get the tangent of a 30-degree angle here?
Shouldn't we know the other sides, or should we just do it?
Is there any way, without a calculator or chart, etc., is there any way to solve this without getting the other sides first?
No, because
No.
in the opposite adjacent.
We have to very quickly go and get these sides, right? So let's just do it. What is, and again, I'm sorry, I'll put this here. So let's call this A, B, and C. Okay.
AB would be 1/2.
1/2.
And then CB, I think I have this memorized, like radical 3/2.
Terrific. All right, great. All right, so now, how do we get the tangent?
Opposite over adjacent, it would be 1/2 over radical 3/2.
Great.
Didn't we do this?
Oh, yeah, of course we did. We did this whole thing, right? Now, hopefully the more that you do this, the easier it becomes to just blast in there and go, okay, I know with the unit circle, that's 1/2, that's radical 3/2. I can just divide 1/2 by radical 3/2. I know exactly how to do it. You have your answer real fast, right? Better than that, especially on a time test, will be literally memorizing your chart, right?
Yeah.
Okay. Well, what? Well, I don't feel like doing it. You're going to have to do it. But let's just figure this out for now. So, obviously, with 1/2 over radical 3/2, what are we going to do? Real quickly, tell me. We just did it. Don't sound so excited.
I mean, I know the answer.
What is it?
It's radical 3.
Okay. I don't believe
What?
that's the answer.
Pretty sure.
No, it's not. It's not. So let's go through it real quick. Tell me what to do real quick. Come on.
Okay, yeah. So set it up. It's radical 3/2 divided by 1/2.
No, it's 1/2 divided by radical 3/2.
Oh.
Isn't the opposite 1/2 and the adjacent radical 3/2? Isn't it 1/2 divided? Right? It's the denominator that divides into something, right?
Yeah, okay. So it's
okay. 1/2 divided by the denominator, radical 3/2, right?
Yeah, okay.
Which is equal to what? 1/2 what?
1/2 times 2 radical 3. 2 over
2 over radical. There we go. The 2's cancel out.
2 cancels out.
Cool. And we have
1 over radical 3.
Okay, and then what?
And then we multiply by radical 3 over radical 3.
Rationalize that denominator.
Becomes radical 3/3.
Radical 3/3. Great. So over here, we know that our numerator is going to be radical 3/3, right?
Yeah.
Okay, cool. What do we need to do now?
we have to find the sine of 60.
Terrific. Okay, great. So that's what we'll do now. I'll just put this over here. We know that the sine of 60 degrees, sine is always going to be what over what?
Opposite over hypotenuse.
Opposite over hypotenuse. Now, if we go back to our unit circle, and I'm just going to draw this in there again, so I'll do it in red so it's easy to see. We can draw up here, down here, and we'll call this D. We'll call this guy right here, we'll call this E. We know that the hypotenuse, of course, is 1, right? What are the lengths of the other two sides? This is a 90-degree angle. What are the lengths of the other two sides?
30, 60.
Good. But those are not sides. But you're right. Those are the angles.
Yeah, sorry, angles. The sides are, we know that CE is 1/2, and
CE is 1/2. Great.
yeah, and then DE is radical 3 over 2.
Terrific. And now, since we're getting opposite over hypotenuse, we can go ahead and do that. What would the opposite of the 60 degrees be equal to here?
The opposite of 60 degrees is radical 3 over 2.
Radical 3 over 2. The hypotenuse is?
And 1.
1.
Radical 3 over 2.
Great. So we figured out that the sine of 60 is equal to, and this is a different problem. We know that the sine of 60 is equal to radical 3 over 2. So we can just go ahead and put radical 3 over 2 here in the denominator, right?
Yeah. Cool. It becomes radical 3 over 3 divided by radical 3 over 2.
Let me write that down. That sounds great. Radical 3 over 3 divided by radical 3 over 2. What do we do next?
Flip it. It becomes radical 3 over 3 times 2 over radical 3.
And now?
Question. Could you cross cancel with radical 3s?
Absolutely.
Okay, cool. So they just become 1s, and it just becomes 2 over 3.
All that work, and our answer is 2/3.
2/3, yeah.
Right, and so looking at tangent of 30 over sine of 60, could you have ever imagined that it would be such a simple answer as 2 over 3, right?
Not really, actually.
Right, okay. Very good, very good. Any questions about what we're doing here?
No questions.
All right, cool. Let's do another one. Let's say the sine of 45 over the tangent of 60. How are we going to do that problem?
Okay. Damn, oh my god. We have to do a unit.
Now, yes, go ahead.
I mean, we already. Oh wait, do we know the tan of 60? No, we don't. Oh my god. Okay.
All right, so you'll either memorize it or you'll make one chart and just look off of that chart over and over again, right?
Yeah.
Okay. I don't want to keep torturing you with making you figure it out. So why don't we go back over to our chart real quick, and we can just go and get the sine of 45. It'll be a lot easier, right?
Yeah.
Let's see if I can find this here. Okay, what's the sine of 45?
Radical 2 over 2.
Great. And then I said divided by the tangent of 60, which is what?
Radical 3.
Great. So we'll just go and throw that into our, if I can find it again. I'm getting lost. There we go. All right, so it's going to be radical 2 over 2, you said, divided by radical 3.
Radical 3.
All right. Now, obviously, we're not finished here, but the rest of this is fairly simple, right? What are we going to do?
Yeah. We just set up a division problem where it's radical 2 over 2 divided by radical 3 over 1.
Cool.
And then after that, we just we flip it, so it becomes radical 2 over 2 times 1 over radical 3.
Okay, which is equal to what?
Which is equal to radical 2 over 2 radical 3.
Keep going.
And then we have to get rid of the radical in the denominator, so
Great.
multiply by radical 3 over 3, so it becomes radical 2 over 2 radical 3 times radical 3 over radical 3.
Great.
And the top becomes, because if you multiply radicals, you can combine them, I'm pretty sure.
Absolutely, right? Absolutely.
Radical 6 over 2 over 6.
Yeah, over 2 times 3 or 6. Anything else?
No.
No. That's our answer. Radical 6 over 6. Great, great, great. So you can see that the unit circle is actually both really helpful for solving all kinds of trigonometric problems, and at the same time, you may see it a little bit torturous at first. But it gets a lot easier. You're just going to have to get that unit circle very firmly embedded in your brain and start using it a lot, and memorizing that chart helps a lot as well.